Okay, for this problem, it says a rotating light is located 11 feet from a wall. So this is 11 feet here. The light completes one rotation every 2 seconds. Find the rate at which light projected onto the wall. So just imagine it's going around and around and around and around. It's like this is moving here. Find the rate at which the light projected onto the wall is moving along the wall when the light's angle is at 10 degrees from perpendicular to the wall. So when we're at a 10-degree angle, so that's when our theta equals 10 degrees. And I guess we can call this distance here. I'm just going to call it x. So a couple things that we have to look at. What we're after is our dx dt. How is that changing on the wall? How is this point changing? And so that's our big question mark. Then let's just go through the steps for this problem. We can relate this angle because we're given angular change here. We can relate angle and these two sides so that what function deals with the opposite and adjacent, and that's tangent. So tangent theta equals x over 11. And since we're looking for dx dt, I'm just going to solve for x. X equals 11 times tangent theta. This part here is important. The one complete rotation every 2 seconds. That means one rotation is 2 pi, and we do it in 2 seconds. So this is in radians, and this is in seconds. So that reduces to be pi radians per second. So because we're going to take a derivative with respect to time of both sides here, and x would be a function of time, theta is a function of time, we're going to end up with a, well, we're after dx dt, but over here we're going to end up with the d theta dt. So if I take the derivative with respect to time of x equals the derivative with respect to time of 11 times tangent theta, on the left I get my dx dt as I want. On the right I get 11 times secant squared theta times d theta dt. So that's part of the chain rule with implicit differentiation, because we're assuming then theta is a function of t, and we know our d theta dt. We know that right here. This is our d theta dt, how the angle is changing. So that goes right there. Let's put our pieces in. Now, they did say when we're at 10 degrees, so in place of the theta there, we're going to have 10 degrees. I know this gets a little awkward because the d theta dt is in terms of radians, but the angle given is in terms of degrees, but that's just what it is. So if we look at dx dt, is going to be 11 times secant squared of 10 degrees times pi, and this will end up giving us feet per second equals something. Okay, let's put it in here. When I do this in the calculator, secant is not a function, and I have a TI-84 calculator, so I'm going to have to do 11 times 1 over cosine of 10 degrees, make sure the calculator is in degree mode. We square that amount, we multiply by pi. What do we have? 11 times 1 divided by cosine of 10, I'm already in degree mode, squared times 11. okay, times pi. And I get 35.63195407. This obviously takes it further, but I probably say 35.632 feet per second. Hope that helps.